Assalamualaikum and good day. I'm Arshad Zabi Ali Zakafri, reporting live from heart of UiTM Shah Alam, where road safety meets engineering precision. Recent observations around campus have raised concerns over road safety, especially at busy intersections where speeding, misaligned lanes, and poor visibility pose risks to both drivers and pedestrians. Our team is conducting a road safety update under ECG563, targeting real issues like speeding, road surface, alignment, landscape, visual aid, lighting, and infrastructure for vulnerable road users such as cyclists and pedestrians. Using the design for safety approach and engineering best practice, we aim to propose effective, realistic improvement to make UiTM Shah Alam safer for everyone. Stay with us as we uncover the hazards and the solution right here on our roads.
Now, the first design safety element that we did is speeding. So for this speeding, we conduct a spot speed study where we conduct at the road intersection during the peak hour between 4 to 6 p.m. To measure the speed limit of the road intersection, a radar speed meter gun was used. First, the radar speed meter gun was checked to ensure it is in a good condition. We turned on the radar gun. Then, we positioned the radar gun to be in a direct line with the incoming traffic on the road intersection. The vehicle speed were observed for a duration of 1 hour or until 100 samples were collected. For the data analysis, here we have collected 100 samples of vehicles speed at Jalan Cemerlang 1/19. The table are consists of the speed group, mean speed, number of frequency, percentage of frequency, cumulative percentage of frequency, and the multiplication and summation of the data. From the data table, a frequency histogram graph was produced for the speed group and its percentage of frequency. Then, the frequency distribution curve graph was also produced, and lastly, the cumulative frequency curve graph was produced. For the calculation, based on the cumulative frequency curve graph, we are able to determine the percentile of speed such as the lower limit, median limit, upper limit, and the road design limit. The arithmetic mean speed calculated was 29.84 km per hour, and the median speed, which is the percentile of frequency at the 15 or P50, is 26.69 km per hour. For the model speed, which is the highest frequency data, is 27.45 km per hour. The standard deviation and standard error was also calculated to analyze the adequacy of the data for a 95% confidence of significant level. So, based on observation of the road intersection, we can see that there is no speed limit signage and the efficiencies of speed bump at the road. So this could cause several effects, such as the drivers are unaware of the appropriate speed, and it could endanger the crossing pedestrians and could cause conflicts between vehicles. To support our proposal to design the speed limit signage and also the speed bumps, following the regulations in Malaysia, which is Akta Pengangkutan Jalan 1987, Akta 333, in Section 66(1) and Section 71, for the speed limit, to give enforcement in implementing of speed limit signage at road. So the appropriate speed limit that we have found in UiTM campus is around 20 to 25 km per hour. And based on the same sections, so it also gives the enforcement in implementing safety structures of road, such as speed bumps. So in another regulations, which is in Arahan Teknik Jalan 1910/97, it shows the guideline to appropriately design speed bump or speed humps. So for the existing speed bumps, we propose to add the width to prevent any vehicles from avoiding the speed bumps, and we add the speed humps before the first junction in order to improve the safety driving practices and to provide more calming and organized road driving environment. For the solutions and mitigations of speeding, so the first one is we add speed limit signage, which is to give the awareness to the drivers so that they will know what are the appropriate speed for this particular intersection, and this will also be a guide for the driver to maintain safe speeds to prevent any accidents and to promote a safer environment for everyone. Now, for the second solution, we propose to improve the existing speed bumps and also to add additional speed humps at the intersection. So this will allow the drivers to control and reduce their speed when driving at the intersection and will encourage a safe and calming driving experience on the road. So the next design safety element is the road surface. So based on our observation at the road intersection, we have noticed that there is a part which is a damaged road surface with a road surface deterioration, uneven surfaces, and it could also cause potholes. So these road surface problems are caused due to the breakdown of pavement materials from prolonged usage and poor road structure, and also overuse of heavy vehicles. So this could affect on several issues, such as it increase the risk of accidents, cause accidents to occur especially for motorcycle, and it could cause discomfort to the drivers when driving at the intersection, and it could the sudden impacts from the vehicle's tires approaching the potholes can cause damage to the vehicle's components itself. Now, the guidelines to support the proposal for our road surface problems is the standards and specifications for roadworks in JKR, which is in Part 4, Flexible Pavement. It explains about the materials specifications such as bitumen, aggregates, and modification works, and also the maintenance work of the road surfaces. Now, for the solutions and mitigations of these road surface problems, the first one is the road maintenance. So, the road damages and defects need to be repaired promptly in order to prevent from further deterioration, which is we could use seal or patching in the road surfaces. Next is use of high quality materials, which is we implement a high quality pavement materials that is durable and could prevent any excessive failure in the road surface, since high quality material have a high strength characteristics. And the last one is to create an effective drainage systems or surrounding the area of the road intersection to help prevent water from infiltrating the road structure, which will prevent potholes and also water puddles from on the road surface.
Vulnerable road user infrastructure or VRU infrastructure refers to the physical elements or facilities designed to protect road user who are most at risk, which is pedestrian and motorcyclists. According to Arahan Teknik Jalan ETJ 8/86, a guide to road design for urban roads, it is recommended to install zebra crossings at conflict points, especially near schools, bus stops, public facilities, and residential areas. The crossing must have clear visibility, appropriate road signs, and warning markings ahead the crossing. Based on the problem, the proposed solution is to install standard zebra crossing markings, which is white stripes with high reflectivity thermoplastic paint at the most used crossing points. Then install regulatory signage, which is pedestrian crossing and advanced warning signs at least 30 to 50 meters before the crossing, as per JKR guidelines.
Next, the problem that we encounter for this intersection is the alignment. As we can see here, for this junction, the cars who want to turn left will have limited space to turn. So the car will cross the opposite lane, which is dangerous for them and might cause accidents. For this junction, the cars who want to turn left have limited space to turn, especially when the traffic volume is high. So the car will enter the opposite lane, which is dangerous and might cause clash between cars. In order to overcome this alignment problem, we suggest to make curve for this intersection bigger, so the cars will have enough space to turn left safely. According to ATJ 11/87 on section 3.6.3, separated left turn on table 3.6, there is guideline for the turning radius. In this case, the recommended radius for the junction with 20 km per hour speed is around 8 to 10 meter depending on the super elevation. Therefore, by following this guideline, the cars can turn safely without any hesitation. Then, let's continue with the landscaping for this intersection area. As we can see here, the tree is planted too close to the road. In this situation, the trenches has already passed through half of the road length. This creates a dangerous condition. At any time, the trenches could fall and might cause severe injury or death. According to JKR, Nota Teknik Jalan 19/97, planting setback distance under Chapter 4.3, which talk about lines of sight. On Figure 4.2, suggests that for urban road, the large trees and shrubs should be planted at least 4 meters away from the road. These setbacks are crucial to provide vertical and horizontal clearance to avoid branches or trunks posing hazard to the road users.
As for visual aids, the road markings, yield lines and bumper lines are significantly faded. The stopping signs also has been blocked by trees. This may be hard for the drivers to see. All of this can cause hazardous and dangerous situation for pedestrians and drivers that can lead to incoordination while using the road. To address this, several corrective actions are recommended based on RIM GL 8/2004 Part 4 Guidelines of Traffic Control and Management Device and Arahan Teknik Jalan 2A until 2D. Firstly, repaint the bumper surface using reflective anti-skid coating for visibility during night and rain. Next, draw new stopping and yield lines that follow the standard of RIM layout for minor road exits. Next, redraw the ghost island with bright red paint to clearly define vehicle separation zones. Next, conduct regular inspection and maintenance of signage and pavement markings to ensure long-term visibility and compliance with safety standards. Existing street lighting is dim and partially blocked by overgrown tree branches. Tree branches and dense foliage are blocking the light beams, causing shadows on the road surface. At night, visibility is very poor, making it difficult for drivers to see pedestrians or cyclists, especially students walking along the roadside. This creates a serious safety risk and increases the chance of incidents. The lighting poles are not well propositioned and there's no effective aid to guide drivers. This condition does not meet the visibility and illumination requirements outlined in Arahan Teknik Jalan 8/86 2005 and the JKR Manual Facility Keselamatan Jalan. Several mitigation steps are proposed. Trim surrounding trees near lighting poles to allow full illumination of the road. Install cat eyes and flexible traffic cones to guide vehicle paths and warn drivers of pedestrian zones. Add reflective signage at key locations to improve visibility. Readjust the height and angle of lighting poles to comply with JKR standards and ensure uniform lighting across the road. This action will improve visibility at night and enhance the pedestrian safety
and bring the road facility back in line with national safety standard.